Guys, my screen is visible.
Yes, sir.
Sir.
Yeah. So previous class we discussed regarding to the machine learning, right? Each and every algorithm also has been completed, like linear regression, logistic regression, distributed random forest, both supervised and unsupervised learning algorithm we discussed. So today, one more topic we are going to discuss about the deep learning. This is all about deep learning. Okay. So deep learning is a subset of machine learning. It means that it is a advanced level of machine learning. So we have some of the limitations in the machine learning, right? So it works only on numeric data. It can't able to handle the huge amount of data. So that's why we use this deep learning. So the deep learning algorithm can easily train the large amount of data. So if we have 4 GB, 5 GB of data like images, audios, signals, it can easily train. It can easily train. Okay. So simply this is an image. Artificial intelligence is a subset of machine learning. Machine learning is a subset of deep learning. Deep learning is a subset of machine learning. That means deep learning is the in-depth concepts of machine learning, where machine learning is the in-depth concept of artificial intelligence. So this is the things. Now we need to know how exactly this deep learning works. We need to know how exactly the deep learning works. So deep learning works on, this is a process of deep learning working. First, we need to have a data input data. First, we need to have a input data, whether it is in the different formats like numerics or images or videos, any type of things. But we need a input data. After input data, we need to decide which neural network architecture we need to use. Which neural network architecture? Here, architecture defines like a algorithm. ANN, CNN, RNN. Which algorithm need to be defined here? Okay, which algorithm need to be defined there. After that, we go for the learning process. How much like train the data set based on the algorithm. We are going to train the data set. And fourth one, if algorithm require any back propagation. So here two terms we have. One is forward propagation and one more is backward propagation. So forward propagation appear from the left to right, like input data to output data. Whereas a backward propagation occurs from output data to input data, we need to update the weights. We need to update the weights. Okay, I will explain each and everything next. Okay, after that we have a feature extraction. If you require any feature extraction, necessary features, we extract the features, and finally predictions. We do the predictions, and finally we go for the evaluations. Finally, we go for the evaluation. This is the how deep learning works. This is the way the deep learning works. First, it requires the input data. After that, we need to select the algorithm and we need to train the algorithm. So if you require any back propagation, we need to provide a back propagation also. After that, back propagation, we need to extract the features which is necessary. Finally, we need to predict the data and evaluate the data. Okay, evaluate the data. Huh? Yeah, okay, you get it. Predictions, evaluations. Yeah. Next, types of deep learning layers. Types of deep learning layers. So we have a three types of layers in a deep learning, like it's completely of the algorithm. So first is input layer, where we are providing the input data, and next one is hidden layers. So hidden layers has a n number of hidden layers. We can create more than 100, 1000, 10,000. N number of hidden layers can be created, and finally we have a output layer. Basically, we have a three types of layer. One is input layer, hidden layer, and output layer. So hidden layer, which is used to provide the input information, which is used to provide the input information like any type of format, numbers, images, audios, any type of format for the input. We are providing the input. So hidden layer is known as like computation, like it need to be trained inside the layers. It is used to training purpose. Hidden layers are used to training purpose. Mostly we need to create n number of hidden layers. We can easily create n number of hidden layers. And finally, we did have a output layer also, prediction layer. That is also known as a prediction layer, output layer. Okay. Basically, these are the three types of layers which are present in a deep learning. Okay. First is input layer, hidden layer, output layer. These are the three layers which are present in a deep learning. So next, types of neural networks. Types of neural network. First one is Precipitone. Second one is ANN, artificial neural network. CNN, convolution neural network. RNN, recurrent neural networks. These are the four types of fundamental algorithms which are present in a deep learning. So let me discuss about the applications of a deep learning also. So application of deep learning like a self-driving cars, Tesla. So completely Tesla works on the deep learning and facial recognition, facial like your phone cameras, facial recognition. So fraud detection, spam or not spam, we can easily classify. And mission translation also works on like Google Translation. So converting one language to another language. And after that, many more. There is a lot of things present in a applications. Okay, this other comes to the application. Now we are going to discuss what is exactly the Precipitone. So Precipitone is a single first neural network. Precipitone is a first neural network which is contain one input layer and one hidden layer and one output layer. Okay, it's a first neural network. Neural networks means simply it is considered as our brain. That is considered our brain. So in our brain also we have some of the neurons. We have some neurons. So it will connected to one point to one point. Like that only in deep learning also it contains the neural networks. It contains the n number of neural networks. Okay. So Precipitone is two types of things. One is single layer Precipitone. Another one is multi-layer Precipitone. Okay. For consider if with single layer Precipitone, X is a input data. When it comes to the output, it is formed as a f of x. We are applying some functions for the input data. That's why it's converted as a f of x. Okay, that's why it's converted as a f of x. So single like a single layer Precipitone, multi-layer Precipitone. Single layer Precipitone only contains single input and single output, whereas multi-layer Precipitone contains multiple outputs and multiple inputs. So we have two types of methods in a Precipitone. One is forward state and backward state. So forward state means simply it represents the forward propagation. Okay, from the input side to output side. Whereas the backward is the most important propagation. In backward propagation, we are doing weight updates to the neural network. We are providing weights, updating the neural network. So there is some formula. W nu equals to WO minus learning rate of dou L by dou W old. I will explain the things later. Okay. This is a back propagation. Back propagation is mainly used for the weight updation of the algorithm. It is used to weight update for the neural network. If you update the weights, the algorithm tries very well and give the perfect of the predictions. That's why we use this back propagation. One forward and one backward is known as a epoch. Epoch. One forward and one backward is known as a epoch. One forward and one backward is known as a epoch. We define as a epoch. Clear? Done? Understand? Precipitone is divided into two types. One is single layer Precipitone and one more is multi-layer Precipitone. In single layer Precipitone, we have only single input and single output. In multi-layer Precipitone, we have a multiple inputs and multiple outputs. So in neural networks, we have possibility to do the forward propagation and backward propagation. In forward propagation, input data from the input side to data is flow, whereas the backward propagation from outputs to input will come and it provides the weight updates for the neural network. It updates the weight for the neural network. Understand? Yeah, you can note. लिखना ना, you can note. No. Precipiton is the main important for the interviews. They will ask about the precipiton. What is mean by precipiton? How exactly what precipiton? What are the types of precipiton? How explain the function present in the precipiton? If you take the input function x, input as a x, it applies some functions in beta, and it will come out as a function of f of x. F of x. Yeah. Precipiton air types of precipiton. Then one thing you can do. So go from a data profile, you can download it. Okay. So next, what are the things we need to require install for the deep learning? So if you want to work on the deep learning, basically we have two frameworks. One is TensorFlow and one is PyTorch. So mostly TensorFlow we require to use. So TensorFlow is developed by the Google and PyTorch is developed by the Meta, like a Facebook. Okay. So in TensorFlow backend, we work on the Keras. In TensorFlow backend, we work on the Keras. If you like, Keras is a high level API scraper, like it works mostly on the APIs, high level APIs. So if you want to install the Keras, simply go for the Google and how to install the Keras. So pip install Keras. Short form is pip how to install Keras in Jupyter Notebook. So simply if you type the pip install Keras, it will be installed. Yeah. So like this also we can install, or you can have a one more type. So there is a number of formats. So you can also install this is pip install Keras, right? If you want to install the pip install Keras, you can use the pip install Keras for the installing of a notebook. So in the backend, after that, you can go for the installation purpose of TensorFlow also. You can also install the TensorFlow from the backend, like same like a pip install. So next to Thorn, there is some more packages which are like a framework, like a Thorn is a one more, and CNTCK also one. It's developed by the Microsoft. This is a third party thing. Okay, mostly we prefer for the TensorFlow for the execution in the deep learning. So same like this is the installation process of TensorFlow. Pip installed in TensorFlow, and same for the installing of Keras. If you want to see the version of the Keras, pip import Keras as a Keras version, same as a TensorFlow. Okay, if you want to install Thorn also Thorn, it will find the things. Okay, it will find things. This is the frameworks we are using. One is TensorFlow. In the TensorFlow backend, we use Keras. As TensorFlow, Keras, backend of the Keras. So this is the installation there. And we have a mainly important of this activation function. So what exactly activation functions do means, activations are initially components. It is used to it is used to map the input of a data. It is used to map the input data to the algorithm. Okay, it is used to map the input data. So basically, there is some types of activation functions in our deep learning. So first one is ReLU. ReLU means rectified linear unit. It completely works for the f of x is equals to max of 0 comma x, f of x equals to max of 0 comma x. Okay, f of x equals to max of 0 comma x. So it is widely is used, like it is simplifying algorithm. It is a simplifying, it is a very efficient and simplifying algorithm. So if you really rectify algorithm, if we consider this is the range of your data, x-axis and y-axis, ReLU function works like this. This orange line denoted like this. It completely works for the positive, maximum 0 comma z, maximum 0 comma z. Same like that, we have some of the activation function. That means second one is leaky ReLU. So in leaky ReLU, we have some data leakage. That's why we mentioned that leaky ReLU. The function of leaky ReLU is leaky ReLU z equals to 0.01 z if z is less than 0, z if greater than or equals to 0. This is the function for the leaky ReLU. So it's like it's completely works for this. There is a slight leakage of the data. That is a slight leakage of the data. That's why we call it as a leaky ReLU. And one more is irrel. Irrel is like a exponential linear unit where we apply the exponential for the similar leaky ReLU. We explain the exponential for the leakage. F of x equals to a into e power x minus 1 if the x is less than 0, x whereas x is greater than 0. If we apply the function for this derivative of things, f dash of x equals to f of x plus a is less than equals to 0, 1 greater than equals to 0. So this is the function of exponential linear unit. So after that we have a sigmoid function where sigmoid function the data values comes between the 0 and 1. The data values comes to the 0 and 1. So f of x equals to 1 by e power minus z. It is a sigmoid function formula. So we already discussed about the sigmoid in logistic regression. Logistic regression. 1 by 1 plus e power minus tan s of x equals to 2 by 1 plus e power minus 2x minus 1. If you apply this formula, it will convert it minus 1 to plus. Data will convert it into minus 1 to plus 1. Okay. And softmax function is used mostly for the output layer. So it is used more than 2 classifiers. If you have more than 2 classifications, at the time we use this softmax. Softmax function zeta equals to exponential of zi divided by summation of exponential of zj. So this is the formula of softmax. This is a formula of softmax. So this is a practical implementations. So simply importing NumPy as NP and define sigmoid. This is a sigmoid. So sigmoid function 1 by 1 plus e power exponential of minus x. Same tan h and ReLU is a maximum number of 0. So this is the formulas where exactly we mentioned previously. So this is the output of data. Okay, output of the data. So the one more important topic is optimizers. So optimizers plays a crucial role in the training process. So it makes it crucial roles in the training process. It mainly helps to the input data how to train the algorithm. So for example, if we have 1,000 to 10,000 records, so if we push this 10,000 records into the training data, it is possible to train. It makes some competitions or some drawback. That's why this optimizers helps to train the data purpose. Okay, it is completely give like minimizing the data. First one is stochastic gradient descent. So stochastic gradient descent is a thing. It will train the data based on the single data point. So if we have 1,000 records, it will take one record first time and train the data. Again one record, train the data. Again, so if we have 1,000 records, it will take 1,000 times of training purpose. So that is the most computation time. It will take most computation. Like it will take huge amount of time to train the data. So that is the thing. So here the advantage is frequently updating the model. If the data is frequently, if we add a new data also, it will be updated. So required less memory because we are training one by one. That's why it's required less memory. Allows to use to train the large amount of data. So there is some drawbacks also. So drawbacks is a frequency also, like a frequency also noise gradient and high variance. It will provide the high variations between them. So it will take the computational expenses. So to overcome this, we have taken the mini batch gradient. In mini batch gradations, we take the some batches of amount of data. If we have 1,000 records, we take some batches, 100 ones, 100 ones, 100 ones. Like that, we are going to try. So here the data is the same. Like here the single point is taken, whereas in the mini batch we are taking some batches of the data, some batches of the data and training them. So it lead to more stable and convince. It's a lead to more efficient gradient and require less memory too. There is also some drawbacks. So mini batch gradient descent does not have any guarantee output conversions, and its learning rate is too small, and it is a losses of too large data. Okay. So next is the best one. There's a RMS root mean square propagation. Sorry, root mean square propagation. So in this mean square propagation, it's simply like a gradient descent, but we are dividing by the root exponential. We are dividing by the root exponential. It's a formula. Catchy new equals to rho into catchy old plus 1 minus rho into dou loss by dou old whole square. This is a formula works. So we don't require this much of thing. Like we are not implementing that directly. We are simply mentioning the algorithm. Optimizer equals to RMS scope and the activation function equals to value. Like this only we have to mention. Okay. This is a slow learner and RMS scope is adjustable automatically. And there is a ADA grade. The ADA grade is used for adaptive gradient algorithm, which is advanced level of RMS scoop, the combination of both RMS scoop and ADA grade. So this is a new W new equals W old plus alpha divided by new catchy into epsilon into so this is a similar like a RMS scoop, and this is the advanced level Adam is a adaptive moment estimator where we have contained some of the vector plus momentum, where we have some combination plus vector plus momentum. In Adam, we are the idea of RMS scoops and momentum. RMS scoops and momentum. So each and every time the learning rate will be high. Each and every time the learning will be high. So both the momentum and vectors works here. So this is a weight WT equals to WT minus 1 minus n divided by, like that's a running rate, n divided by root of s dw. This is the deviation of weights, and same like bias. So both are the advantage is easy to implement, computation is efficient, less memory requirements. So this is the advanced. It mostly we use this Adam. Optimizer is a Adam optimizer. Clear? So these are the basic fundamentals of the topics, which is in your deep learning. So next we are going to see about ANN and implementation, CNN and implementation, RNN and within the 3 class it will be completed. Micron 2, Thursday, Wednesday, Thursday, 2 days. Here. So this is the introduction of deep learning. Any doubts? Online, do you have any doubts?
Sir.
Okay, then how many people have done the projects? Mishangani project, how many projects do you have completed? Did you completed? 6. What about online? How many people are present in online?